Right, we're on this page in the blue book. What page is it?
4.
4. And in a few more moments, you're going to analyse your data for your pendulum. Now, doing the worksheet that I gave you, you can work out what G is here. I think, by shoving your values of T into and L into your formula. Okay? And then at the end of all this, you'll get a whole value of G's for your trial 1, and you'll get G equals a certain value, G equals a certain values. You add them up and you will then average them. Okay? And then you will do that for every case. This is called statistical analysis. Okay? So what you are about to do is you are going to calculate, because today you're going to make sure that you as a group share and make sure everyone's got the same data. You're going to statistically find the average for your group. Okay? That's the first thing you're going to do. And you're going to get that value out, and we're going to compare it to a graphical approach. The graphical approach takes into account that you may have outliers. So when we are in a few more moments going to a graphical approach, of course, takes a graph like that, and you then draw a line of best fit. Now, when you are drawing a line of best fit, if this is your data, what 2 points would you think, maybe I'm not going to give as much weight to? Right, so we've all pointed to this one out here. This one here is obviously out of position. Okay? Then these 2 points here seem to also be out of position. But when you draw your line, you'll say, okay, I'm going to probably split the difference. I'll probably, so it's supposed to be a straight line, go through those two there. Okay? Now, if you did a statistical method, you would not have realised that these are outliers. They would be in your data, skewing your value one way or the other. Does that make sense? A graphical approach means that you can choose the data that you will ignore. And that gives you greater control over your results. Hopefully, that will become more accurate. To do a graphical approach, like we did this year, we have to get a straight line. You can't use a curve to do a graphical analysis because we need to use gradients. So what we're about to do is we're going to fill in this section here. That's the formula for the pendulum. And so if I was to, at this moment, draw T against L, now T is the dependent variable, and L over here was the independent variable. That's the one that you changed. You changed L and you measured T. Okay? That means that if I was to write this out mathematically, it's 2 pi on root G times root L. I separated the L and the G in that square root and brought them together. If you were putting in Y and X for T, you get Y equals this thing here, which is a constant. So we'll just call it a constant because G is 9.8, pi is a constant, so it's 2, root X. This is a square root graph. What shape do square root graphs have? It's that shape, isn't it? So if we were to plot our data, the data that you got the other day, will you get a straight line? No. Can you use it therefore for graphical analysis? No. So we have to be able to manipulate this data. So what we're going to do is, to get a straight line, we need so that it is y equals mx plus b. But hopefully the plus b will be a 0, so it will go through the origin. Okay? So the way that we are going to do it is we are going to get, remember t is the variable on the vertical axis, and L is the variable on the horizontal axis. So we're going to square both edges, both sides of this equation, so that we get rid of the square root. So we no longer have a square root function. So in doing that, I'm going to write down how you do it. Please make sure you can do this yourself. So squaring both sides, you get t squared equals 4 pi squared L on G. Okay. And the final thing is, remember we want L as the horizontal, the x, and the y is the t squared. So that means that we have t squared equals 4 pi squared on G times L. And that means that the gradient of a straight line that we plot with this data will be 4 pi squared on G. Okay? Are we okay with that? So if we plot t squared on the first axis, the vertical axis, and we plot L on a horizontal axis, we won't get a square root graph anymore. We will get a straight line going through the origin, and the gradient of the straight line is 4 pi squared on G. And that is its significance. The significance of the slope is that if plotted t squared, period squared, against L, the length, you will get a gradient, a straight line with a gradient, and that gradient significance is 4 pi squared on G. Are we okay with that? Right. So that's going down in that point now, state significance. This is, the D here is just part of a larger question that you will be in the rest of this lesson doing. But I've given you a half sheet now to have a look at. Okay? Now, has everyone got the half sheet on the way in? I want you just to follow, because you're going to apply this to your data that you got on last lesson. Okay? So could you create, in a spreadsheet here, length, so type that in there. Just L and make that meters. You don't need to type the word length. Period, and that's second. And then in the column next to it, t squared, and that's second squared. Is simple. Most people, because this is a spreadsheet, you can't use squares. There's no subscript and superscript. So you just go T2, S2. Okay? Rightio, type it in. Okay, once you've done that, you have to first thing it says create a plot of these two pieces together. So there's L against T. Now, the reason why I've got this here is just make sure you can all do a scatter plot. You can't use a line graph. You know Excel does not have the ability to do proper mathematical graphs. So the only one that is mathematical in Excel is the scatter graph. So to do that, you use the insert. You highlight the data you're about to plot. Okay, and the first column is going to be the horizontal, and the second column is going to be the vertical. Right, so you highlight your data. Please don't highlight the columns, the column headings. Then you go to scattergram up the top, and I don't choose the one with the curves on it, just the plain old one, and there it is there. Okay. Okay, it always gives you this little series thing here, deleting that. And you can press these chart layouts to make a grid. And I don't want it linear. There. This is actually, it's power. Don't worry about it. Okay. It looks like it's a straight line, but in reality, is it? No, it is a curve. It is actually this shape. Okay, so it's not good. Okay, so that was just to show you that it will not work. Okay, are we okay with this? Rightio. Okay, moving to the next one now. So just delete that. Right. We now need to create a t-squared graph, a t-squared column, I should say. And the easiest way, are we able to use Excel? Excuse me. Right. If you can't use Excel, remember this is where you do it, the formula for one cell and then ask the whole thing to do the same thing. You use an equal sign to start your process, and we say I want this squared. Now the squared is the hat key, which is the key above the 6. So it's shift that and 2 and then equals. If you don't like that, you can just say that cell multiplied by itself. So you could say C3 times C3 or whatever you want to do. Okay, and then you highlight it down, and then you use Control D to fill down. Okay. Now, you want to plot this column here, that column there, against that column there. Now, the way you do it, we need to highlight this column and this column. Now, there's 2 ways of doing this. One where you hold down the Control key and highlight one and then the other, which I'm going to try and do. I'm never very successful at this. Holding that down and then that one there. Are we okay with that? And you can see only those 2 things are now highlighted. And you ask it to insert a scattergram again. Please do not use the curvy ones. Oh, that's bad. That's what I get all the time.
I got that too.
Okay.
Yeah, I got that. I got a graph.
You got a graph? Okay. Everyone gets it wrong or right. Doesn't matter. It just sometimes the computer, it's all individual to the computer. Notice this, it doesn't work. So let's not fiddle around with it. This is what I always do. Have a look here. I just copy this data over here into another column. And I now copy this data into this column here. Okay? So just copy, cut, sorry, not cut, but copy and paste beside each other. Are we okay with that? Because every time I did that a few moments ago, I've always got that one. But if I use one of your computers out there, I get the right one. Then highlight those 2 and do it again. Insert a scattergram, that one there, and woohoo! Get rid of that series crap. Make it a little bit more square. Okay. Press the auto format button, which is this one up here, and that turns on all the grids, makes it a little bit more useful. It puts the series and the linear series back together. I don't know why it does that. Okay. It always wants to make a line. So I want you to you'll automatically put that line in. But we're going to click on that line and then go right click. And then you're going to format the trend line. Okay? And the most important thing you are going to do is we're going to display the equation of that line on the chart. See this button just here? Can you see it? That one just there. Turn it on. Right. Now, that says that this line here, don't worry that it doesn't go through 0, 0, 0, because really it's a line of best fit. It shouldn't go through 0, 0, 0. Everyone got it? Okay. Repeating, listening. You click on the line, then right click. That's right click, and it's format the trend line. On that format trend line, down here it says display equation on chart. Okay? And then ask it to close, and there is the equation. Now, the reason why this is important is it automatically does what? If this is y equals mx plus b, what is the gradient of this line? It's 4.0246, which we'll just do to 5. Are we okay with this data? Right. In that case, we now know that we have got this axis over here is t squared. This axis is L. So we have t squared equals 4.025 times L. This is the gradient. The significance of that gradient is m is 4 pi squared on g. Could you now do a calculation? If this equals that, then 4.025 equals 4 pi squared on g. Could you calculate g, please? Okay, so that means it's 9.8. Now yours is not going to be exactly 9.8, it should be slightly less. Okay, the reason why yours will be slightly less is that this the friction at the top should slow the pendulum down a bit. It's not a perfect pendulum. And not all of you brought the pendulum back to just a small angle. You might have put it back a little bit too large, and therefore you start allowing other effects to take on. But it should be reasonably about 9.7 on average. Okay. Are we happy with how this is done? Right. The last question on that sheet is, the last question. Identify 2 reasons why the accuracy of the data will be considered high. Accuracy is how close the value is to the actual value. We actually got 9.8, so we are actually on value. So that's the first reason why. Could you have a look at the data itself? Look at that data point there. How many decimal places is it? 3. So therefore, I am confident that this period has been measured down to 6 thousandths of a second. That's the level of accuracy that the instrument is allowing me. So the instruments I've used can measure down to thousandth of a second. So I'm not using a grandfather clock to measure the period, am I? Grandfather clocks could only measure to each second. Okay? So there are 2 reasons why this is considered, the data is considered to be accurate. Firstly, we are very close. In fact, in this case, we are identical to the expected value. And secondly, the data obtained is to a high level of precision, which means it's got a high level of significant figures, or in other words, the machine that I use to measure it can measure down to very small increments of time or length. Is that clear? If I was to ask you to measure the length and I gave you only your hand spans, how accurate would your data be? Not very, okay? Because you can only measure to the nearest hand span. Is that making sense? Rightio. Any questions on this data model? Because you're now going to apply your data to this. So rather than starting everything from scratch, you don't have to get yourself a new sheet. You just simply go to sheet number 2 here. Give yourself a blank sheet and start this process again using the data that you got the other day. Okay, off you go.